There is an invisible bottleneck in global information sharing. Billions of critical records are trapped in physically degraded, yellowing archives. Optical character recognition, or OCR, is the technology used to convert images of text into digital data. When faced with water stains or faded ink, free OCR tools like Google Translate fail and output gibberish. The standard alternative is sending these files to a premium human translation agency. Humans can decipher to poor scans, but the process takes weeks of turnaround time and costs up to 1,500 rupees per page. Plotting cost and time against legibility tolerance, free tools are stuck in the low-cost, low-tolerance sector, while human agencies occupy the high-cost, high-tolerance space. Look at the top left quadrant. Here, Lekhak.app AI enters, offering high tolerance for damage scans without extreme costs. The actual friction point in modernizing global archives is the physical decay of the paper itself, not the language written on it. Lekhak functions as a specialized extraction engine built specifically to rescue these difficult texts across 22 Indian languages and over 100 global languages. It processes these heavily damaged files in 3 to 5 minutes, achieving a 95% accuracy rate. Utilizing this system requires a specific trade-off. You give up the guaranteed perfection of a premium human agency and commit to doing some minor manual proofreading yourself. In exchange for that brief proofreading, you cut costs by orders of magnitude, get your text back in minutes, and recover physical archives that other services simply reject. The decision to use AI translation here relies on a simple calculation. Does correcting a 5% margin of error take less time than typing the document from scratch? The first step in Lekhak's 3-stage pipeline is Vision First OCR, a system designed specifically for non-standard physical media. This specific computer vision model targets the physical anomalies that break standard converters. It reads through 15-degree skews, extremely low contrast areas, and heavy watermarks. Let's look at what that means in practice. The system extracts text from tightly packed, non-standard historical scripts that feature chaotic visual noise, like faded right underlines and ink bleed. Because the source material is heavily damaged, the AI will occasionally misread an obscured character shape, requiring a human to spot-check the output. Even with those occasional misreads, the vision-first approach rescues the physical media from permanent loss and turns it into a workable digital first draft. Once the text is extracted, it moves to the second stage, contextual translation. The AI automatically analyzes the text to determine if it is reading a legal contract or a patient's medical history. It then adjusts its vocabulary to ensure the terminology matches correct industry standards. Raw OCR data funnels into the contextual AI, translating content across 22 Indian and major global languages. As it translates, the system maintains the exact structural layout, preserving paragraphs, margins, and headers. By preserving the industry-specific tone and physical layout, the translation process retains structural meaning instead of outputting a literal text dump. The final step driving the platform's accuracy is the ensemble verification pipeline. This is a multi-AI validation layer built to hunt down OCR hallucinations. An OCR hallucination is an incorrect character or word generated when the initial scan misinterprets chaotic visual noise. The validation layer cross-references the text to automatically fix perp and date formats, correct misspelled names, and resolve character confusion, like mixing up a capital I and lowercase l. Running these checks results in an average of 22 automated corrections per document. This intensive cross-referencing is exactly why the process takes 3 to 5 minutes rather than delivering instant results. For sensitive archives, the system applies end-to-end encryption during processing. Once the final translation is ready, the temporary processing files are immediately deleted to maintain privacy. That deliberate 3-minute processing delay is the exact mechanism that cuts a professional's manual editing burden down from hours to mere minutes. We can see how this pipeline performs when applied to strictly regulated industries, where accuracy is heavily scrutinized. In the legal sector, professionals use the platform to rapidly digitize decades-old property deeds and court records across multiple Indian languages. Medical facilities apply it to convert notoriously difficult handwritten doctor's prescriptions into digital electronic medical records, or EMRs. EMRs are the digital versions of patients' paper charts, and the system digitizes them with nearly 95% accuracy. Language service providers use it as a high-margin, first-pass tool to process illegible 1980s marriage certificates that they previously had to reject. Lekhak functions as an efficiency multiplier in these environments, provided a junior staffer verifies that final 5% of text to ensure strict legal or medical compliance. The financial return on investment is straightforward. Instead of paying human agencies between 300 and 1500 rupees per page, the AI pricing starts at just 25 rupees per page. Removing hidden fees and per-word charges allows for the translation of entire archives that were previously too expensive to process. To lower the barrier for entry, the platform offers the first 10 pages for free, requiring no credit card or long-term commitment. Find the most degraded, poorly scanned physical document in your files and upload it to test the vision-first extraction yourself. Physical degradation is no longer a valid excuse for losing historical or professional data. The technical barrier to digital